Every year, a space rock the size of a person hits Earth and releases an amount of energy similar to the Hiroshima atomic bomb, 15 kilotons of TNT. This is equivalent to the average electric power consumption worldwide, a few terawatt, for 20 seconds. The likelihood of a close passage is proportional to the area of the target. Since the Earth-Moon distance is 60 times bigger than the radius of the Earth, this means that similar rocks pass within the Earth-Moon separation 3,600 more frequently, or 300 times per month. They pass within a sphere delineated by the orbit of the Earth around the Sun a few billion times each year. It is therefore not surprising that an asteroid twice this size passed at 3,589 kilometers above the surface of Earth as recently as January 26, 2023. The asteroid, called 2023 BU, was spotted 5 days earlier by the amateur astronomer Gennady Borisov, who is also known for discovering the first interstellar comet in 2019, J2I Borisov. Are there any implications of the above statistics to the search for extraterrestrial intelligent life? In 1937, Olaf Stapledon published a science fiction novel titled Star Maker, in which he imagined, as the eons advanced, hundreds of thousands of worldlets were constructed, all of this type, but gradually increasing in size and complexity. Many a star without natural planets came to be surrounded by concentric rings of artificial worlds. In some cases, the inner rings contained scores, the outer rings thousands of globes adapted to life at some particular distance from the Sun. It began to avail itself of the energies of its stars upon a scale hitherto unimagined. Not only was every solar system now surrounded by a gauze of light traps, which focused the escaping solar energy for intelligent use, so that the whole galaxy was dimmed, but many stars that were not suited to be suns were disintegrated and rifled of their prodigious stores of subatomic energy. The concept was subsequently formalized by Freeman Dyson in his 1960 science paper, titled Search for Artificial Stellar Sources of Infrared Radiation. Dyson reasoned that as the energy needs of humanity will steadily increase, our civilization might aspire to tap all the energy output of the Sun. He proposed a shell of orbiting structures that would intercept and collect the solar luminosity. This so-called Dyson sphere would emit infrared radiation to balance the heat deposited on it by sunlight. Optical emission from the solar surface at a temperature of 5,780 K would be balanced by infrared emission at a temperature of 400 K from a spherical shell at the Earth-Sun separation. Such infrared emission at a peak wavelength of about 7 microns could flag a Dyson sphere relative to the natural optical UV emission by sun-like stars. So far, searches for the related infrared signatures from stars or galaxies did not find evidence for Dyson spheres but merely emission by natural dust. In a new scientific paper, Professor Avi Loeb from Harvard University suggested that even if Dyson spheres existed to serve their civilizations for a while, most of them would have disintegrated within billions of years in the absence of extensive maintenance. In that case, their fragments could appear as unusual interstellar objects. As shown in the textbook Loeb wrote with Manavi Lingam, Life in the Cosmos, rigid Dyson spheres are not easy to keep together. In compliance with Newton's iron sphere theorem, a perfectly spherical and rigid shell is not subjected to any net gravitational force from a star interior to it, regardless of whether it is centered on the star. However, the shell experiences destructive differential forces across its surface, and its material strength must be unrealistically high in order to prevent deformation. The required strength is an order of magnitude above our toughest engineered materials, such as graphene. To circumvent this challenge, Robert Forward proposed a tiled structure, with each unit functioning as a solar sail for which the star's gravity is exactly balanced by its outward radiative push, thus maintaining a fixed position without orbiting the star. If another civilization constructed a Dyson sphere which broke up and disintegrated over time, its fragments could have given rise to the unusual shape and light sail characteristics of the interstellar object Oumuamua, or to the unusual material strength exhibited by the first and second interstellar meteors, IM-1 and IM-2. In approximately 2 months, Professor Avi Loeb and his team will attempt to retrieve fragments of IM-1, and whatever they find will be particularly interesting in this context. But irrespective of its initial architecture, a Dyson sphere would be a maintenance nightmare since it will be punctured by a few billion human-sized space rocks every year. Over a few billion years, the structure will have holes of a few meters in size every 100 meters. Interestingly, the estimated size of Oumuamua was about 100 meters, potentially dictated by the bombardment rate of an old Dyson sphere. Smaller holes will be far more abundant. The holes will cover a significant fraction of the pre-existing Dyson sphere surface from bombardment by micrometeorites on sub-centimeter scales. This impact statistic is measured empirically now, as the Webb telescope is being hit by a dust-sized particle every month. Without repair, a billion-year-old Dyson sphere would resemble a large fishing net which lets a substantial fraction of the starlight out. Once a civilization abandons its Dyson sphere, the shell's infrastructure will be punctured by micrometeorites and lose its functionality within billions of years. Rather than hovering around a star as a source of energy, the advanced technological civilization might choose to develop its own artificial fusion reactor, which could be portable and useful for propulsion through interstellar space. The first clue that humanity is capable of embarking on this path was demonstrated on December 5, 2022 by the National Ignition Facility, NIF, at Lawrence Livermore National Laboratory. Next on our agenda is to develop an interstellar fusion engine. Once we learn how to light the fire, we might not need to build a Dyson sphere around the natural furnace represented by our Sun.